Hello everyone, today we'll talk about the solution to the problem target sum. When we read the statement, we see immediately the standard pattern of a 2 to the n problem. We have some positions before each integer, so let's say we have n positions. For every position we have a binary decision, so we have two options, either a plus or a minus. So the number of all the possible sequences of decisions is 2 to the n. And that would be the most basic approach to solving this problem, would be to just enumerate all of them, all 2 to the n possibilities, and see in what number of possibilities we get the appropriate value for the whole expression. That can typically be achieved most easily using recursion, where we have a set of positions, so we, let's say, take the first position, and first we set it to plus and enumerate all the possibilities for the rest of the positions, and then we set it to minus, again enumerate all the possibilities for the other positions, and we have enumerated all the positions that we have, all the possibilities. And in this case it's possible to optimize that solution slightly by using memorization. That's because if we know for the set of remaining positions what values we can achieve from those positions, then it doesn't depend on whether or not we put a plus or a minus on our position. So essentially, when we are deciding what to put at position 0, and we have a set of all the possibilities, of all the results, values for the expression that is the whole expression without the position 0, then we have that set, and either we can add to all the values of that set the first integer, right? Either add it or subtract it, depending on whether or not we put a plus or a minus. Which means that we don't have to calculate the set of possibilities for all the other positions twice. We can calculate it once and then we remember it, and for the other possibility we can return it. So that would be the memoized recursive solution. We can use the cache decorator in Python to get that essentially for free. This is a single line modification to a typical backtracking, typical recursive solution, exponential one. Or we can do it bottom up, and in that case we'll be adding numbers one by one to the expression that we're building. So we are looking at the prefixes of the expression, and we'll be maintaining the number of ways in which you can generate every possible value using only those first numbers. So at first we start, and we'll be maintaining it as a counter because that's the most natural class in Python to maintain it. At the beginning we have no numbers, so we can only create value 0 in a single way. And now for every new integer, we'll be generating all the values in this variable next dp. And now, for every value that we could have generated before, so we start with only value 0 being generated in a single way, we can generate a value of either plus v or minus v. And so for the next value in this pair of either plus v or minus v, we add the number of ways we can generate this previous value to the number of ways we will now be able to generate the next value. We can get the result for the previous step, and the result of our current step becomes our dp. At the end, we went through all the numbers, and so our dp has a number of ways of generating every possible value using all the numbers in the input. We're interested in the number of ways of generating target, so we just return dp of target.